Distinguished participants and dear guests, in our last session, before passing to the last session, with the partnership of the Turkish Exporters Assembly and the Finance World Journal, we would like to welcome you to the Forum Istanbul 2021 conference. And we would like to thank our strategic partners as well, and also our session sponsors. APS, Deniz Bank, Gülsan, Turkish Economic Bank, Turkish Telecom, Big Brands, and the Dünya Journal. And in the last session of today, we'll be talking about how digitalization of health will change the future. I would like to once again remind you that throughout the session, you can use the Istanbul Forum 2023 hashtag. And on the other hand, from YouTube and Facebook, from over the Dünya Gazete, you can actually follow all the discussions. We are waiting for your questions and comments. And we will be talking about today in the session, how can virtualization in healthcare can improve the quality and span of human life. A powerful revolution is coming. Synthetic biology. How will synthetic biology, which is behind the discovery of the COVID-19 vaccine, change our future? What are the huge opportunities and risks in the future with genetic design, protein production, and natural product synthesis? How to use the blockchain in the healthcare industry with features such as security, transparency, and real-time monitoring? What is the importance of 5G for the health ecosystem? How do we standardize healthcare services with telemedicine and robotic care? And as a moderator, I would like to invite here Mrs. Servet Yıldırım, the board member of Forum Istanbul, and also our speakers. Professor James J. Collins from Termeer, Professor of Medical Engineering and Science, MIT. Mr. Volkan Güçlü, Gene Therapy, Global Commercial Strategy, Sarepta Therapeutics. Barış Karakullukçu, Turkish Telecom Ventures Board Manager, Turk Telecom's Chief Strategy Planning, Business Development and Digital Officer. Professor Dr. Ali Rıza Kural, former President of the Endocrinological Society, Robotic Surgery Specialist. And the floor is yours, sir. Welcome. It's a very deep, actually, theme that we're going to be talking about, a very important one, and actually a panel that I was awaiting for a long period of time with very great excitement. And of course, I was used to be working about COVID-19 for a long period of time, and still I can have actually time to think. Well, every day when the daily patient numbers are released, and when I see all the doctors and nurses around, I just think about on how we have come up to this. And of course, spiritually, we are also broken. And it seems like we felt quite desperate. And I was thinking about last year, April and May. There were so many things that were not determined, that were not really clearly certain on where we will be going to. When we first knew about the coronavirus, many things have said. They said that it wouldn't contaminate human to another one. And they said, on the other hand, we will start with new agents. During that period of time, the scientists said that after certain amounts of mutations, these viruses would become more actually acquainted by the body. There would be actually dogs that would determine the people who were sick instead of using long PCR tests. Now, months have passed. None of this happened. And if there is some that happened, that wasn't very effective. That is why COVID-19 actually proved how vulnerable we are, how actually delicate we are. Even though science has improved so much throughout the years, it wasn't that much. At least that was my thought. And we were thinking about drones that would actually be used as weapons for certain cities or countries or regions, which would demolish those areas. We were just thinking about these things. We were thinking about blockchain, etc., but we never thought about the COVID-19, and we just actually were shaken. And we thought that the governments would take actions as soon as possible, but they didn't. We believed in the organizations. For instance, we said that so many countries are coming up together and there's a giant structure called the World Health Organization, and we thought that they were doing everything. But it was a virus coming out from a Chinese bazaar, a zoonotic one. And we realized that the World Health Organization was just a balloon. And now that I am not very optimistic right now, my personal view perhaps, but I can say that we need some more hope right now. Of course, it wouldn't be a hope that would be void. It should be supported with information and knowledge. And in the panel that we are going to be talking about, we will be hearing a lot of great information from our panelists. And I hope that I can get more informed by what they are going to tell us. So our theme is how digitalization of health will change the future. First and foremost, I would like to welcome you all. And I would like to, first of all, invite Professor Dr. Ali Rıza Kural, because he's going to be in an operation in the meantime, so he has to leave the panel. And the floor is yours, sir. Yes, thank you very much for your invitation. I would like to thank Ms. Özlem Özgencin. And this is going to be recorded. I guess this panel is going to be recorded, and I want to also listen to the next sessions as well. However, unfortunately, I have to leave just after my speech. What I have to do today, I'm going to be talking about telemedicine, where we are right now, particularly in the case of COVID-19. As Mr. Servet has wonderfully expressed, this catastrophe has indeed struck us and has made us think more. I'm sorry, I cannot hear. The speaker is muted. I guess you can hear me now. Yes, okay. Allow me, please. Yes, I'm so sorry. Well, technology can bring up some certain challenges indeed. So can you hear me right now? Yes. All right. I was talking about telemedicine. What is telemedicine? Well, we need to define it. We all know it perhaps, but telemedicine is actually a type of a health service that is used for protective medicine in order to make diagnosis and treatments for diseases remotely through information technologies. It has first been started in the 20th century. The first one, the electrocardiologic findings have been transported to one place to the other. And later on in the 50s, the radiologic screenings have been also sent to 24 kilometers of distance to Pennsylvania and Philadelphia, Winchester. But the first documented and via video, the first documented medical and communication via video was made in 1959 in the Nebraska University, where they were used in telemedicine, particularly in protective medicine. And also due to the fact of the reality of COVID-19, we have the opportunity right now to make online examinations, and on the other hand, a remote patient control and visits. Besides, on the other hand, it can also be used in operating a patient remotely. And in another study that has been made in the recent time, 5 billion people cannot receive the necessary health services. And again, approximately nearly 150 million people, so that they can continue their healthy lives or not to lose a limb, they do not have the possibilities to have an operation, a medical operation at all. Now, the World Health Organization and the other organizations are right now working on many other different types of skills and things. Telemedicine, however, is still right now taking its baby steps. But the main idea of it is to clinical support, make a clinical support, or to make accession to the patients and physicians who are not at the same geography or in the same location. And on the other hand, different types of information and communication technologies are used. The aim here is to improve the health conditions here as a basis. In 2015 in the United States, in California, particularly for elderly patients, a telemedicine application has been done, and it has been seen there was a 95% of patient satisfaction. And they were sending and scanning all the information through the videos, and the physicians were examining them and were giving the medical treatments. It also created an additional $126 of additional saving as well. Besides, how do we create that communication between the doctor and the patient? FaceTime, WhatsApp, Zoom, and Skype, Google Hangout, or some certain platforms that the health institutions provide. And now maybe not perhaps through video conferencing, but through e-Nabız, which is actually an application that has been founded in Turkey by the Ministry of Health, that also can be done. But now, through this e-Nabız, we can actually find any radiographic scannings of the patient. There are certain limitations as well. What about confidentiality? Now we have to come over these confidentialities. I mean that we need to keep these, and security issues are also a challenge that we're facing. And another issue here is, for instance, on the level of national health system, while we are making such connections with the patients and the doctors, there is no reimbursement in our country yet. But in developed countries, and particularly in private health institutions, these also can be made, but they all are things that have to be done within the context of regulations. And of course, particularly, Mongolia, which has a very wide landscape, it is one of the largest 12th or 13th country, and the population is very low accordingly to that. Now, let's say there is a patient who lives in a very remote area to the physician. So this is all about a great burden. And that is the reason why, with the support of UNFPA, between telemedicine and particularly any complication that is caused through birth, and in order to decrease the number of newborn deaths, a new program has been started in 2007 between 2011. So indeed, they have the experienced physicians have taken over 798 problematic births and made all the necessary diagnoses and treatments. And of course, all the different types of tests can also be made through this digital platform. We can share it, as it is seen that these 798 problematic pregnants, 62% of the mothers did have a problem during birth. 21% of the mothers have a gynecological disease, and 15% have a newborn disease. So as a result of this, complication rates dealing with birth has been declined by half, and also the death rate has been declined in newborns threefold. Of course, COVID-19 is a factor that brought up telemedicine so close to us. When COVID-19 has first started, the United States and France and the United Kingdom and also in other countries, they haven't made certain type of implementations, but first and foremost, France has made implementations. In March the 9th, 2020, France, through its National Health Ministry, decided and agreed upon the reimbursement of national health insurances made over video teleconsultations. So between the dates of 23 and 29th of March, is 486,369 video teleconsultation invoices have been provided. Now here we have the symptomatic patients, and they have been evaluated through telemedicine. For instance, a patient had a contact with a person having COVID-19, and they are also regarded as infected. And all the video teleconferencing questionnaires gave the opinion that certain people could be quarantined or could be hospitalized or could be dwelt and given medicine at home. So if there are certain amounts of people who were hospitalized, they were immediately sent to the hospital. The asymptomatic patients didn't need to go to the hospital and didn't actually take time off the physicians, also the hospitals. And actually that happens in our country as well. The Ministry of Health created a system, and with that system, they are following the patients and they are bringing up the contamination possibility. So a year ago, France has started the study and other countries followed. And I suppose due to the new technologies, and particularly digital technologies, where countries are using, have to do it. Otherwise, the hospitals cannot actually meet the needs. So how does telemedicine happen?
This is a robot. This is not a live patient, and he is anesthetized. This is, by the way, real drug, and equipment in the robot here senses this medication, and the swallowing and also the respiratory pipes are relaxed. If it is wrong, it gives alarms, it warns you. And the mentor on the monitor, even though she might be or he might be kilometers away, endotracheal tube placement is mentored here. Here you can see. On one side, he or she watches, and on the other side, they might be mentoring their students. So IV drugs are given to the patient, and intubation has been made. Patient is ready for an operation. The systems could be used for trainings, and also trained anesthesiologists and trained fellows, doctors, exams could be made possible with these equipments. Here, this is a remote robot, remote controlled robot. It is on the hospital corridors. Very recently, this has become very common place. Here you can see maybe doctor is at a very distant place, and I don't know, but here you can see the resolution is very clear. So thanks to that, patient and doctor could be talking to one another, so he doesn't or she doesn't need to go there. So this is great. Again, this is remote surgery and about telesurgery, or else it is about a remote surgery or offline surgery, or a place that is different from the operation room. We have been watching this kind of videos for many years. This is from the United States Navies and Air Forces. Based on a project from the United States military forces, we can see that if there comes any injuries of the soldiers who are fighting abroad, they can be transported to a hospital scene thanks to the help of robots. Here you can see that soldier, or else that patient, a bullet has gone through and it has been scanned, and a robot made the injection here. Everything is being controlled by people, of course. Robots are not doing these by themselves. Maybe this is the ideal thing. And here the injury, the wound is closed. These are some utopic things, but what is the real phenomena here? In the year 2001, New York and Strasbourg, having 14,000 kilometers in between these two cities, laparoscopic cholecystectomy surgery was performed by Zeus robot. This is the first transatlantic surgery. This is maybe the first primitive robot. And French surgeon Maresco operated a patient within 54 minutes from New York to Strasbourg. I'm repeating again, from New York to Strasbourg. Yes, this is very crucial. So time delay, this is the most important thing, because you are using internet services here. A satellite is hired, and through that satellite, you carry out your communication. Here again, there is time delay. It is 155 milliseconds. This is the real images of that operation. So this is a Zeus robot, and here, as you can see, surgeon is there, and with certain hand manipulations, he commands the remote instruments, and everything is the same. And these are some of the surgeons from France. By the way, I know some of them, and they're watching the surgery. And you need to remember one thing: there are human factors where operation is carried out, because they place ports and some operational instruments, and surgeons also transport some materials that are necessary inside the operation room. This is not a system which works just by itself. This is a master and apprentice system. Okay, now let's talk about another telesurgery or telerobotic remote surgical service example. It is again from Canada. This is the square meter of Canada, 9,905,000 kilometer, and I believe it is the second biggest country of the world, and the population is not that high, so commute of patients from one place to another place is very difficult. And here there's a study involving 21 telerobotic surgeries between two experienced centers. Hamilton is the main center, and main surgeon operating the patient was located in Hamilton, and the other one was located in another place, which was 400 kilometers away. The Zeus robot was used in the surgeries, as I've stated before, and in terms of resolution, everything was very, very good, and a satellite was hired, rented, and thanks to that satellite, operations were made possible. And there was only some small things, there was not a significant complication. When it comes to time delay, it was again 130, 140 milliseconds. During COVID period, another telerobotic application was made in Canada. Here, in between two centers, we see 600 kilometers, and La Loche had the main unit, and Saskatoon is the following center. So they were following the pregnant there. Actually, ultrasound was observed by a surgeon or by a physician on La Loche, and in Saskatoon there was only a nurse just guiding the ultrasound, guiding the patient, and up to 81% they got positive and satisfactory results. On the first and the second trimester ultrasonography monitorization in one fetus, they couldn't detect heartbeats, and in another pregnant woman in the fetal structure, they detected some anatomical congenital structure distortions. So knowing it in the early senses, of course, can provide you big advantages. So there are many examples like that from remote controlling systems, but this is all I just want to share you as examples. And this is also another doctor performing 5G technology. This is another robotic surgery. Kangaroo robot tried to be developed in China. And here you can see the surgeon is about 50 kilometers away from the OR, and he uses instruments, and pigs were used for liver resection. And in this 5G system, latency was, the time delay was 100 milliseconds. So compared to others, time delay was shorter. And again in China, micro robots, this is another robot type, 2-arm surgeries were made. And it has been into the literature. So all in all, I can tell you that in telemedicine, teleconsultation applications have already been settled in certain branches like dermatology. For instance, you can send a photograph to your physicians. On your skin there could be lesion, and you can also send some pathological complications, and I've witnessed to that. So even your dermatologist could be kilometers away from your place. They can just prescribe you the drugs and you can be treated. And in the pathology, of course, many things have developed very swiftly in our country, in Kayseri, in Adana, some places where Acıbadem Hospital is also present. We can see great examples of remote examinations in pathology branch, and also during surgery, surgeon wants to know about the pathology, that frozen pathology, whether there are still cancerous cells, etc. So instantly it is possible to make the evaluation from Maslak, which is the center of Acıbadem Hospital. In radiology, in psychiatry, this is again the same. Maybe in other branches it could be different, but on the surgical treatments, using such a system is not very much realistic. But when it comes to medical treatments, I believe that there are many more potentials that we can get use of. So in today's conditions, like we are having right now, Congress, even patient consultations can be carried out on Zoom or GoToMeeting or some other platforms, and it is very efficient. Of course, seeing each other face to face is very different, I know that, but sometimes, I mean, you can have your meeting in your house and you just go to your bed with your pajamas directly. This is something different as well. This is something nice. And also, public health of the less developed countries is very crucial. The World Health Organization and some other countries attach importance to that, but we have to be considering public health more and more, and through these kind of technological advancements we can also help public health improvements for less developed countries. Telesurgery is just taking its baby steps, but we can imagine right now, and I'm sure that in 20 or 30 years of time, better things will come. And last but not least, I want to say one thing. Maybe we had telemedicine in the past. Yes, we were using it, but COVID-19 pandemic just made us much more awake, and we need to use technology, and it showed us that we could use technology. Thank you very much for your patience. Thank you so much. And in the second round and in the last part, I hope and I wish you better discussions. Thank you very much. Thank you so much. You have an operation. You need to go to the operation room. Thank you very much for your presentation. Thank you. I'll give the floor to Professor James Collins. He's a professor in MIT, and he'll be talking about synthetic biology. Yes, we'll be talking about synthetic biology. This is something very new, but there are many questions in that, and there are some legends when it comes to synthetic biology. It could be misused. Is it correct to intervene in the nature? What happens if a synthetic organism leaks or escapes? Who is going to control synthetic products? Who is going to be using them? We know that it is pushing the limits in medicine. Synthetic biological research are pushing the limits, and there are many designs that they are working, and much more important that we can understand influenza types better, and in order to have vaccination, synthetic biology is used. In the first round, I'd like to ask COVID-19 pandemic effect and synthetic biology. The floor is yours. The floor is yours. Maybe we can start with the effects of synthetic biology over COVID-19. We can start with this question. The floor is yours.
Thank you. Well, I very much appreciate having the opportunity to speak to you all. Of note, I actually visited Istanbul in 1988 as a member of the University of Oxford basketball team, where we stayed and played in a tournament at Boğaziçi University for over a week and had one of my most enjoyable life experiences. So I hope as we come out of the pandemic, I'll have a chance to visit again your beautiful country. I really have some things to share in this exciting emerging field of synthetic biology. As many of you know, it's about 2 decades old, and the field is focused on bringing together engineers with molecular biologists to use engineering principles to model, design, and build synthetic gene circuits and other molecular components, and to primarily use these to rewire living organisms and cell-free systems, endowing them with novel functions for a variety of applications. We and others helped launch the field in the very late 90s, when we recognized, just as an electrical engineer can come up with a circuit schematic for an electrical circuit, we as biological engineers can come up with a circuit schematic for a biological circuit. And whereas the electrical engineer would seek out molecular components, resistors, capacitors, inductors, and solder them onto a breadboard to create an electrical circuit, we recognized that you could seek out molecular components, genes, promoters, other bits of DNA, RNA, and use the enzymatic tools of genetic engineering to encode those components into a circuit in DNA that could then be transferred to a cell or tested in a cell-free system for its functionality. These circuits were initially used to reprogram living cells, and these are leading to new classes of living diagnostics and living therapeutics. But in the context of the COVID-19 pandemic, synthetic biology has had a major impact. It's really been the coming of age year for synthetic biology, primarily in cell-free contexts, systems being developed outside of cells, though still interacting with cells. Let me speak first to the synthetic mRNA vaccines that were developed by Moderna and Pfizer. As the organizer indicated, these vaccines have origins in synthetic biology. We were fortunate to be part of the team that co-developed the synthetic mRNA technology that led to the founding of Moderator. This was an effort that goes back 10 years ago that was in collaboration with Derek Rossi and George Daly. Derek became one of the founders of Moderator, and George is currently the dean of Harvard Medical School. What we did was recognize that there was an opportunity to engineer mRNA so that it could be delivered directly to a cell without need for using viral vectors. But in this case, our initial interest was to do it in the context of stem cell reprogramming. So in 2010, now I guess it's 11 years ago that we did this work, there was a lot of interest in reprogramming mature cells to become induced pluripotent stem cells. This was typically done using viral vectors, which had its limitations. With Derek and George, what we did was modify mRNA, changing up its nucleosides so that it could accomplish several things. One was that it did not trigger a cellular immune response. Two, you could have robust expression levels. And three, you would reduce the degradation of those expressions. This worked brilliantly. We could now deliver Yamanaka factors directly to a cell and have those translated into the cytoplasm stably and robustly to produce proteins of interest, creating induced pluripotent stem cells, and then introducing additional transcription factors that enabled us to translate these, convert them from iPSC cells into any cell type of interest. We published this in Cell Stem Cell, and in the paper, two things to know. One is we did note in the discussion that this was a platform that could open up RNA vaccines as well as RNA therapeutics. And second is that Derek revealed he was launching a company, then pronounced Mode RNA, which now is pronounced Mrna, to actually clinically translate these. And along with his other founders, the team decided to focus on therapeutics instead of regenerative medicine, as well as then responded beautifully to the current pandemic and produced a remarkably effective mRNA-based vaccine based on this technology. I'm hopeful that this will open up the world to many additional vaccines. I think this will be challenging. I think, oddly, I'll use the phrase, I think we got lucky with this pathogen, and that had a very clear target for the vaccine with the spike protein that could serve to trigger immune responses to render the infections ineffective. And we'll see if that turns out to be as effective for other schemes. In the context of diagnostics, synthetic biology has had a dramatic and important impact, and largely, again, in the cell-free context. We recognized going back 7 years ago that you could play with cell-free systems in a way different from others. So a cell-free system is this idea that you can open up a living cell, take the machinery of that living cell outside the living cell, which would consist of DNA, RNA, ribosomes, other molecular machines, various molecules, and play with them in a test tube or petri dish. We recognize that you could take those cell-free systems, spike in a synthetic biology construct, and freeze dry them onto paper. And then sometime later, rehydrate what had been freeze dried on paper. And you could reactivate those cell-free systems in the synthetic biology constructs. They would function as if they were inside a test tube, inside a petri dish, inside a living cell. And we initially did this in the context of developing antibiotic resistance diagnostics. But as we were publishing this work in 2014, we then turned our attention to using it to address Ebola. In 2016, we actually addressed the Zika crisis and developed paper-based diagnostics that we used as part of the outbreak. So we developed paper-based diagnostics that we used in 6 different countries as a surveillance tool and research tool. In the context of the current pandemic, we had advanced our efforts to not only using traditional synthetic biology constructs. Sorry, I have landscapers outside of my study window this morning that you don't need to hear from. But we also used CRISPR elements that could develop highly sensitive diagnostics. And Feng Zhang of CRISPR fame and my collaborator friend, he and I launched a company called Sherlock Biosciences to advance a platform, paper-based freeze-dried platform we developed around CRISPR called Sherlock. And the company was launched about 3 years ago before the pandemic, advancing molecular diagnostics to address a range of infectious diseases. In February of 2020, when the pandemic hit, the company, with our collaboration, turned its attention to the pandemic and developed COVID-19 CLIA lab diagnostic that had 100% sensitivity, 100% specificity at 1/4 the cost of the PCR test and could deliver a result in 1/6 the time. It became the first FDA-approved CRISPR-based product in the medical space. It was released, we developed a partnership with IDT to produce 1 million such tests each week. And the company has formed partnerships with 3 global diagnostic firms to develop and conduct many million such tests each year. And Nepal has adopted this test as their country's national COVID-19 test. Notably, I, for one, don't think that anyone should profit from the pandemic. And we formed accordingly a nonprofit foundation called the 221B Foundation, where it's doing three things. One, making available all of our IP to any for-profit or nonprofit group that would like to use CRISPR technology to develop COVID-19 products. Two, we're donating all of the profits from our products and any of those to the foundation. And three, the foundation's using it to support STEM efforts around the globe to help underrepresented minorities become more engaged in STEM. The final example on how synthetic biology has impacted the pandemic is related to these cell-free efforts. 7 years ago, we uncovered that you could freeze dry onto paper, but we also learned that it wasn't limited to paper. And that is, you could freeze dry cell-free systems along with synthetic biology constructs onto any porous media material, including cloth, textiles. And so we advanced an effort to create a wearable synthetic biology platform. And prior to the pandemic, the idea was you could create wearable diagnostics that could be used by healthcare professionals, first responders, military personnel to report if they've been exposed to a pathogen and or other nasty chemical. In the context of the pandemic, we decided to apply to see could we create a COVID-19 face mask diagnostic. And the idea was quite simple. Could we introduce or develop a small insert that could be added to any face mask? And the notion would be you'd wear this and the normal act of coughing, talking, sneezing, breathing will give off water vapor, water particles, water droplets that if you're infected will contain the viral particles that could be then diagnosed or detected with our cell-free freeze-dried system. We developed a foldable, paper-based, microfluidic lateral flow assay that consisted of a collection zone, an amplification zone, lysosome, amplification zone, and detection zone, and output region, and developed a system that could detect down to 500 viral particles, which could be collected in a matter of minutes, in a wearable face mask that had incredibly high sensitivity and high specificity. We could differentiate circulating coronavirus, COVID-19, from other coronaviruses, and now have multiplexed it to detect not only SARS-CoV-2, but seasonal flu. So we're very excited about where this could go, largely as a surveillance tool, but not diagnostic tool. And looking out, and in the second section, we'll probably address additional topics, but I do think synthetic biology, this idea we can engineer biology for positive good, will become a defining technology of this century. Thank you.
Yes, I'd like to thank you very much.
Yes, and while we were talking about telemedicine, let us continue from over the COVID-19 period of time, and let us talk a little bit more about the digitalization, digital transformation. First, can you hear me? Yes, okay. I first and foremost would like to thank the Dünya Media and also the Istanbul firm, and also would like to thank all the panelists. To me, well, this organization, I am one of part of this conversation, which is celebrating its 20th anniversary. And as far as I know, during the course of the panel, rewards have also been given, and one was given also to me. So I would like to thank you as well. So when we continue talking about COVID-19, as it is said before, telemedicine has taken a lot of steps throughout the pandemic and also increased the amount of communication between the patient and the physician. So, of course, there are many plus sides of the COVID-19. And as you know, throughout the health sector, there are plenty of regulations and we need to be very attentive, which is very understandable. And on clinical trials, particularly in many other areas, there have been some certain limitations or constraints for certain companies. And throughout the COVID pandemic, the certain limitations have been overcome through technology. And as you might agree, technical studies are very much important throughout the pandemic. Of course, a new innovation has occurred. And throughout the whole world, artificial intelligence became highly prominent during the detection of COVID-19. So the people companies dealing with the health sector, universities, lecturers, professors have all come up together, and many publications and many investigations and researches have been made in a very short period of time. As Mr. Collins has said, during the COVID phase, there was actually a great amount of knowledge that have been shared, and many valuable studies have been completed. Indeed, we have seen some positive aspects of the COVID-19, but of course, some certain limitations as well. Telemedicine, and as for when we take a look to telemedicine, and also from the production point of view of medical drugs and also clinical studies, there have been many developments made. Yes, of course, there have been limitations and constraints. We are still under challenge as a world. And however, there is still hope now, and we see the hope. There are developments going on, and positive ones. And if I evaluated myself in general, I in particular think that the COVID phase has developed the machine algorithms and also the artificial intelligence. And of course, wearable technologies are also very prominent right now. There are plenty of developments going on in that sector. There are plenty of companies, without naming them, indeed do have wearable technologies, and those technologies are becoming a great help for receiving data. And there is a great innovation about that indeed. This is, of course, giving us hope, but we need to be very attentive, by the way. We need to be very attentive on how the data is collected properly. And during the COVID time, yes, there were challenges, positive sides, but in the end of the day, of course, it is a period of time where everything accelerated quite fast. And I am hopeful. And I also would like to underline that the synthetic biology, yes, indeed, is very much important for cell and gene therapies. These there is very for gene therapies. These new synthetic biology is very much important, and I believe that it will create a new dynamism in this area. And as a result of this, actually, apart from the challenges of COVID-19, we see that in research and development and through innovation, it was a great time of learning. And a great amount of research has been made, and ethical decisions have to be given. And also we are going to see how everything will go further innovatively. This is how I can actually briefly summarize the COVID-19 period in implementation. Yes, we're talking about a great pandemic. 3.5 million people have died. Well, the World War was also a global catastrophe indeed. And indeed, such catastrophes, unfortunately, in one way, it is also helping us to develop. And now I would like to give the floor to Barış Karakullukçu. And you are actually this Chief Strategy Planner and Business Development and Digital Officer. We're talking about 5G right now. From the point of view of the health sector, what did 5G brought up to us? Thank you, Mr. Servet. I also would like to thank you for being here and be part of this panel. And I learned a lot of things from our speakers. Without repeating my colleagues, as from the side of telecommunication, I'm going to be talking about our approach to the health sector, and I try to explain what 5G means in that matter. And we are one of the largest brands in Turkey that is making investment in this area in 5G. And indeed, because we try to give value to the people in this last year, of course, health is naturally an important issue, but pre-pandemic, in verticals, health was one of the 3 sectors we gave importance already. And if I have the opportunity in the next rounds, I have some examples to share with you. And if I talk a little bit more about 5G, Mr. Ali Reza has made a wonderful introduction as he was talking about telemedicine and as he was talking about the transformation of health. Now we are talking about a new health world, and 5G is also a recent situation, a recent subject, and Deputy Minister in the previous sessions, and also the Turkish General Director of Huawei have underlined the importance of 5G. So this is a really precise issue for us. 5 years ago, it might be a little bit more vague, but as our company, we are continuing our developments on 5G, and Turkey is starting its experiments right now. Now, health sector, of course. In health sector, we're talking about remote operations, and particularly where there's a necessity, this is very meaningful. But without having a 5G, without having a communication, this is not possible to make, because due to the fact of the necessity of information transactions, we need to have a great amount of a high speed, and so that it can be implemented. In the meantime, we are preparing our technology for it, and we are trying to make up business models for that. Besides, we are also studying on the applications which are made in the world, not only the operations, but also in follow-up. 5G is also becoming very important. PwC has made a wonderful report about that, particularly the new health is a 4P, predictive, preventive, personal life, and practice. There are four articles for that, as PwC has said. So that preventive health sector can be viable with 5G. So everything will be customized. It will be different for Mr. Volkan, Mr. Collins, or Mr. Servet. So with all the tools that is following me, I am using these tools in order to come over any kind of a health issue that might occur. And many people are actually making investments upon it so that any kind of a disease can be predetermined. And because we're talking about the pandemic, we've seen also in Wuhan, in a hospital, this has been used. There were robots that were checking out the fever of the patients and making other things as well. So the 5G technologies and right communications can only provide this. So in Turkey, we have a goal that we call 2023. But we are not waiting for 2023, of course. We are totally making developments on these use cases at all times. And I can maybe later give you some certain examples about this. All right, and we can go on further with the examples. And now, can we continue? Yes, Mr. Collins. So yes, we were talking about the synthetic biology. Synthetic biology is very enthusiastic and a very exciting area. And it's we're talking about here engineering, and it's a very important scientific field. So it can be also a solution to many problems. And I would like to ask you, synthetic biology, how can it change the biotechnology? Can we get a little bit more detail about that?
Yeah, so the field is still relatively young. I do think it's moving from an emerging field to a maturing field as we speak. Interestingly, there's only a few hundred, 200 to 300 academic labs around the world, but over 800 companies in the field that have been formed. So there's been a strong translational focus, particularly toward biotechnology. I think that many of the spaces have been relatively small on their impact, but the general notion is, can we expand the ability to use living cells, be they bacteria, yeast, plant cells, mammalian cells, to produce various proteins or other products of interest. So increasingly, it's moving beyond the initial efforts in biotechnology for getting after protein-based therapeutics to looking at higher end commodities that could include various lubricants, lotions, for example. The field in its early days, so back in 2004, made a very strong effort toward bioenergy. So engineering microbes in particular to convert foodstuffs or sunlight into fuels. This was motivated by then a number of factors. In the United States, it was the first time gas had gone north of $4 a gallon. There were geopolitical interests to reduce the US reliance on foreign oil. A number of oil companies were looking for alternatives, and governments were looking to back these efforts, as were investors. Unfortunately, it was overpromised of what we could do. It's no question you could program these microbes to convert foodstuffs or sunlight into fuel, but they did so at significant inefficiencies. So scaling up an academic effort of a 10-liter bioreactor to a 1,000,000-liter bioreactor turned out to be highly inefficient and economically not practical. At best, companies that had had hundreds of millions of dollars poured into them were producing $1 worth of fuel for $8, which was a business model that was not sustainable. And unfortunately, investors and innovators left that field by the late 2000s. Why I think it's unfortunate is that the overpromising, I think, killed an area that could be incredibly valuable for us going forward. Soon, we will run out of dinosaur remains as fuel sources. And as we go beyond fossil fuels, we'll need alternatives. Having an option to produce $1 worth of fuel at current prices for $8 still is impractical. But if we continue to innovate and move that down to $4, $3, $2, it becomes an alternative that is reasonable and a replacement for reducing reserves. And so I think we need to turn back to that space. Increasingly, I'm seeing groups very interested in using synthetic biology to address challenges in food and water. For example, with our colleague Julius Lux at Northwestern University, we showed you could develop paper-based diagnostics that could be distributed into the field to detect heavy metals, pathogens, and various toxic chemicals in water supplies at very low cost, opening up possibilities where you could screen for systems. We've worked with a company called Sample 6 that engineered bacteriophage initially to break up biofilms that exist in bioreactors as well as air conditioning systems, but then moved to engineering bacteriophage to serve as food pathogen sensors that actually now have been distributed to food processing facilities worldwide, with over 1 million tests being conducted using that test. On the agricultural side, I advised a company called Indigo Ag that is using synthetic biology to create synthetic ecosystems of bacteria that are then delivered to seeds to endow the resulting plant with enhanced properties. So I think synthetic biology will be addressing challenges in energy, challenges in food and water, and I'm increasingly seeing interest now to turn it toward other challenges in climate change and sustainability. I think we'll see, for example, increased efforts of using synthetic biology to enhance our ability to capture and sequester carbon from the atmosphere, whether it's in producing plants that utilize more efficient forms of photosynthesis, programming vegetation to grow faster so that you have larger coverage, as well as modifying microbes to enhance such plants and potentially enhancing heat tolerance for coral reefs and other schemes. Looking ahead, a lot is being driven by consumers, but I turn back to healthcare. I think in addition to the areas I spoke to, synthetic biology now from the living side is having advances on programming bacteria, for example, to serve as living diagnostics and living therapeutics. We did so to show you could reprogram a bacterium found in dairy products to detect and treat cholera. This effort led to a new company called SynLogic that now has 3 clinical trials underway, where they're engineering bacteria to go after 2 different rare genetic metabolic disorders, as well as a treatment to go after solid tumors, and are advancing efforts to program bacteria to deliver protein-based therapeutics to treat inflammatory bowel disease. And as alluded to by one of our other panelists, we also are advancing efforts to use synthetic gene circuits to create next-generation gene therapies and advanced cell therapies, like CAR T cell therapies and CAR NK cell therapies. And we've launched a company called Sherlock Biosciences. It's being led by Tim Liu, one of my former students and colleagues, that's now formed partnerships with Spark Therapeutics and Blue Rock Therapeutics to do just that, to use synthetic gene circuits to create next-generation gene therapies and cell therapies. So it's very early in this field, but I've seen in the last 2 decades a shift from more artisanal approaching to design to now industrial and commercial clinical grade design that I think will be transformative across many sectors in biotech. Thank you.
Well, thank you. And now in the second round, I would like to give the floor to Mr. Güçlü. Let us talk about the gene therapy. The gene therapy is very much debated nowadays. What is the gene therapy? What do you think what will happen? Now, yes, gene therapy is a very popular subject, and as known, clinical studies have been made so far, in particularly the United States, China, and then Europe is very much accelerated in their studies about this. When we talk about the gene therapy, as for it is used as a terminology quite actually frequently. And the definition of gene therapy is also been, has a broad sense. So we need to talk about the gene therapies. So the aim of the gene therapy is like molecular antibodies. In the 70s, all these studies have started in the 70s, and human studies have been initiated first and foremost in the 90s. And on 2003 in China, gene therapy has been initiated, and on 2008, excuse me, on 1996, unfortunately, in the studies of the United States, there have been a great loss. One of the participant patient died. And of course, that caused a great cessation in that field because the technology, there was also a necessity to actually to develop that technology in that manner. And taking a look at this, the gene therapy since the 70s is regularly developing. And on 2012 in Europe, and on 2016 in the United States, there are certain gene therapies that are implemented. And today, globally, there are some certain neurological diseases, and that in which gene therapy is used, and on certain eye ophthalmological diseases. So in single cell bounded, the target is to have a treatment in single cell bounded diseases. So now we're talking about the cell treatment and also gene treatment. Gene treatment has also some certain subtitles. Every gene treatment, it doesn't necessarily mean that every person can benefit from the gene therapy, but sometimes, as you know, the gene that is lacking, that is missing, can be transferred. This is called gene transferred. In some places, with certain biological mechanisms, they cut it, they operate it, and they put it into the cell. Actually, this is intervening the nature of the person, but it's a very new one. Now, what we're talking about right now is a gene transfer. And the gene transfer has two basic applications. One is in vivo, which can be injected directly, systematically, or locally to a person. And the second one, ex vivo. Now, the cells are taken from the patient, similar to the cell therapies. So the bone cells are taken here, and then with certain manipulations, interventions are being made in the lab, and the same cell of that patient is re-injected to the patient. It's called ex vivo. So then the in vivo transfer is generally been used as a terminology right now. I suppose when we talk about gene therapy, the people are expecting different things. Okay, we're going to make the gene treatment and everything is going to work. Well, in some diseases, it can happen, but in some it cannot. When we go back again, there are some certain single cell problems. Sometimes these problems are very big, sometimes very small. And these, there are vectors, adeno-associated vector particles, and AAV particles do have a very important role, and this has been started to be implemented nowadays. And again, let me just, right now, the molecular antibodies in the cancer drugs, at first there wasn't enough of them in it. So in the gene therapy, we do have the similar thing. In production, there is a certain constraint, a limitation, but very rapidly, the innovations are being made, and this has been about to be overcome. There are immense amount of studies that has been made, and developments and productions is opening also a path to the gene studies as well, which is also an important point. And another thing here is that gene treatments, how gene treatments will have a place in the health economy. And again, these new therapies in Europe and in the United States have certain constraints and also some certain debates. Since 1.5 and 2 years, there are drugs in Europe and Japan and also in the United States. There are new different types of models of them. And as you know, the gene therapy can only be done once. And the vectors that are implemented, the vector particles, the body becomes more actually resistant to these vectors. And the efficiency can lower or can also cause certain risks. The number of risks can rise. So hence the case, there are different types of ways to do it, because our immune system, as we know from the viruses, have a great role. And that's the reason why the gene therapies, on the other hand, first you are taking a foreign pathogen, an alien pathogen, and your body can actually react to that. And you also need to take these into consideration as a risk. So during the production with the innovations and with the clinical innovation studies, and also with the regulation and from the point of view of economic health economy, very important steps have been taken, but we are still in the beginning of the road because many clinical trials are ongoing and new information arise, and in many meetings these issues are debated in the States and also in Europe. And then from then on, it seems likely to be we will be having a more better way of using these gene therapies. Well, as I told you before, I may had this gene therapy and I will be fine. So is it really so? That's a question mark. And that's the reason why it's very exciting as an option of treatment. Well, we will see in time. But again, I will return to the COVID period of time. It also has affected the studies for COVID, but there's a reality here from clinical trials. Indeed, the COVID-19 does have also some negative aspects towards these studies. As for the point of view of balance, the gene therapy, briefly, is a gene, the vector or the gene, a version of the gene is coded, and then it is also locally or systematically returned back to the body, and after it passes the immune system, these particles come to the cells, and after the synthesis, the necessary protein or the protein that is lacking returns back to normal. Well, we see that the proteins are very much important. So in gene therapy, the most important thing here is that the extraction of a protein, mRNA. That's why gene therapy is very new, but it's very exciting. Developments in the world, in Turkey, of course, is a little bit lagging behind because we need to make a lot of research and development and finances as well, so that we can understand all these matters properly. So gene therapy is overall and in general, like I said. Yes, the floor is yours.
Maybe we can have another panel about this. And last but not least, I'll give the floor to Ms. Barış Karakulukçu. I'm really curious about what you do in your own area with respect to health, because it is a reflection of the theory into practice. What are the things that you can give us as examples? Thank you very much. Thank you so much. So on one side, when I was an advisor, we were always thinking of the future. We were always discussing about visions, because we were always imagining 15 years, 20 years from our time. But right now, I can see that there are many things that we need to solve when it comes to pandemics, especially in recent periods. We have already experienced a lot of things together, especially I'm sure that many people have lost one of their relatives in the last 1.5 years ago. In the last 1.5 years, because I lost my father. It is not necessarily COVID, but this is such a period that we understood the real importance of health, because it is at the very center of our lives. We remembered it, and we try to make it even better. Yes, I'm an engineer, but we try to learn from the physicians. We try to understand about the body's mechanisms. We try to understand it. And also we are trying to deal with the data on the analytical world. We make all our jobs with data. And I have been dealing with digital transformation in the last 20 years. And I have seen that. If we include more technology and digitalization into our jobs, if we can think of the issues in a more concrete way, not in intangible ways, we need to think how we can make more people healthier. If we can think about it, I believe that we can use all the KPIs in a better way. We can leverage those KPIs in the health field. When you think of my workplace, I mean, I work in Türk Telecom. We are not like Mr. Collins' organization, of course. We are not a non-profit organization. We are also responsible for digitalization of Turkey. So in this kind of difficult periods, we work very hard to provide better benefits to our society. And we have many strategic partners. And I believe that we have already delivered very good outcomes from our projects to the community. Online health consultancy and preventive medicine, these are some of the important things that we have been working on, especially since the very beginning of this pandemic. Isolation and affiliation monitorization systems have been advanced by Türk Telekom. I think we are the biggest company supporting these systems. So apart from that, there could be other systems. There is a project called Smart Organ Carrying Bags, for instance, with Ankara Güven Hospital and Professor Nadire Çetinkaya. We have designed a project. Organ donation is not a very high level in Turkey. In order to keep the organs safe, in order to keep them fresh for the next surgery, and when it is kept fresh for the surgery, it must still be followed very, very closely. So we have already implemented a project in the pilot phase, but we have also another project that we are proud of in Sami Ersek Respiratory and Cardiovascular Hospital. We have also had a remote project. So 540 patients have been followed and their information have been tracked and shared online on the online platforms with their mobile phones. So at the end, these follow-ups, their health-related data have been advanced and their health status have become better. And atherosclerosis is one of the very significant and prominent journals of the world. We published the results of our study, and we have Innova, which is an affiliated company to our group. We are very much ready to provide any kind of services to the hospitals. Türk Telekom Ventures is another affiliated group that my team manages. Half of the investments that we make here is related to health startups. So health sector is one of the prioritized sector for us, and we have very successful examples out of this investments. Virasoft is one of the successful companies that we are very proud of. Virasoft works on cancer area diagnosis rate of Virasoft tries to Virasoft works in order to increase the success of the diagnostic estimations and rates. So it already increased the correct estimation rates up to 96%, 97%. And there is also Dr. Turkey. Ali Rıza Bey has already mentioned that in terms of remote management and remote interviews, Dr. Turkey is the first example of all the future steps, and we are going to support it so that it won't be just the only one. And we also have developed an incubation center, and we already have given 8 periods graduates out of our academy, and we want to support and endorse startups in the early phase when they start working. So health, I mean, without waiting 5G is very crucial. I'm not objecting to that. It is going to be the reality of our lives. It is going to open new doors for the health. But of course, before we reach to 5G, health data must be utilized in the best way so that citizens could be given better choices. Technology must be adopted much more frequently in our lives. It must be placed at the very core of our lives. We have to be supporting our people. As Türk Telekom in this field, we are ready to support every enthusiastic parties we can support and we can endorse them. Thank you very much. Thank you so much. Thank you, Professor Crown, Professor Collins, and Ms. Barış and Volkan Bey. Thank you very much. In the beginning of this presentation, I already mentioned that I was very pessimistic because I had a very severe coronavirus period. For that reason, maybe my belief even has weakened. But based on your comments, I can say that there are future there is great potential for future, and we have already made great advancements. So right now, my hope can be enriched based on the information that I have received from you. Thank you very much. I would like to thank each and every panelist. Thank you so much. Forum Istanbul has underlined important facts for many years, and I would like to thank the organizers of Forum Istanbul. Thank you very much again.